Today we are going to be looking at 7.2, doing some problems out of that section, and I'm going to warn you up front, this is a really long section. Okay, so what I have done to try to shorten this lecture portion is that I have actually sent you these pages of notes that I'm just going to read through briefly, some of the highlights here on this lecture, but I'm going to send these out to you, and you guys should print them off, make notes as I go, or just read through them. Okay, it'll, in theory, save you some time from actually having to read the book and stuff and write them down yourself. So if you're somebody that learns better writing them down, you may still want to do that, but a lot of this is just some definitions and stuff that you really won't be responsible for, but you kind of have to know that to be able to do the problems. So anyways. Alright, so what is a matrix? Because we're in matrix algebra now. Hopefully you saw this in Algebra 2. I think it was in Chapter 3 of that, so that was obviously a while ago, but it should be just kind of a refresher here. Let M and N be positive integers, and M by N matrix is a rectangular array of M rows and N columns of real numbers. And so it starts out A11, A12, all the way to A1N, and this goes all the way down from A11, A21, all the way down to AM1, and ultimately to AMN. A shorthand notation is AIJ, okay, where I and J are representing the rows and columns of this particular matrix. We have the elements, which are the letters and numbers within the matrix. The first subscript I is the row subscript, and then you have columns, so the reverse alphabetical order. Okay, row, column. So rows come first, then columns. The order of the matrix, okay, that's, again, like I said, M rows and columns. If M is equal to N, then we have a square matrix, so that means the same number of rows and same number of columns. We have equal matrices if they have the same order, meaning if they're both the same, like M times N, and the corresponding elements are the same. So this will be useful for a couple problems that we do there. Matrix addition and subtraction. Basically, if you have two matrices that have equal order, so they both have to be the same, like M times N, okay, then we can add them together and we can subtract them. So it's just like your normal, just adding, you add each element up. So like 1, 1 goes with 1, 1, 1, 2 goes with 1, 2, and so on and so forth. Let's see. Scalars are the next thing. So basically they're real numbers. So we say let K be a real number such that the product of K and the M by N matrix is K times A, or then we basically just multiply everything inside by K. So every element gets multiplied by K. Now notice this is scalar multiplication. Okay, eventually we'll do matrix multiplication, and that is different. The zero matrix, okay, this is an O. Okay, this is matrix O. Any matrix M times N that consists entirely of zeros, so you could have infinitely many zeros in a matrix, okay, and we would call that the zero matrix, or matrix O is the way we'll refer to that. Additive identity, so basically we have the zero matrix, or matrix O, because, and that's the identity because when we add that times, or plus any matrix that we're given, so any M by N matrix, we get out that matrix that we had. Okay, so it follows the same rules of just basic algebra. Additive inverse, basically you have matrix B, which is the opposite of A, so A plus B is equal to 0, or you could say that B is equal to negative A. Alright, matrix multiplication, which is going to be kind of the big topic out of this section, but with this, it looks confusing seeing it written this way in a sense. Because when you multiply two matrices together, you have to make sure that things line up so that you, basically if you have an M times N matrix, okay, or here they use M times R, so let's just use that. You have an M times R matrix, or an M by R matrix I should say, and then you have an R by N matrix. Because these R's are the same, okay, these two middle things have to be the same, we get a resulting of an M by N matrix. And I know this is confusing right now, but we're going to do examples to see what I mean by that. Okay, but if I were to flip this and do B times A, then I would have R by N and M by R. M and N don't match up, so that wouldn't be possible. But again, like I said, it'll make more sense in a minute when we actually start doing some problems. Alright, the identity matrix for N by N. Basically, this has ones on the main diagonal, which is this upper left to the lower right, and zeros everywhere else. So that's what I've tried to kind of show here in this matrix here. And then this is the multiplicative identity for that. So we have the zero matrix, which is the additive identity, and then we have the multiplicative identity, which is ones on the diagonal and zeros everywhere else. Inverse of a square matrix, let A be equal to the matrix A sub ij, B an N by N matrix. If there is a matrix B such that AB is equal to BA is equal to that identity matrix, KI, the identity matrix. So if you multiply A times B or B times A, you should get out that identity that has the ones on that main diagonal. If that's true, then B is an inverse of A, and we can write it as B is equal to A raised to the negative 1, or A, you can say A inverse. Alright, it's non-singular, and this isn't as pertinent to what we're doing, but just so you're aware. Non-singular, so A is non-singular when the square matrix A has an inverse. If it doesn't have an inverse, it's singular. So they're kind of opposite from what you would think. No inverse goes with singular. Inverse goes with non-singular. So it kind of seems opposite, so just remember what that is, opposites. Let's see, inverse of a 2 by 2 matrix. You can do the inverse of any matrix. Okay, you can find the inverse. However, the only ones that you would be responsible to actually find the inverse for are 2 by 2 matrices. Okay, I'm not going to require you to do the other ones. So to do that, we have if AD minus BC is not equal to 0, then, so we're taking the inverse of this matrix. We have 1 over AD minus BC. Okay, and this is what you're going to find out to be the determinant in just a second of the matrix. But we have 1 over AD minus BC. We flip these two. So this was A and this was D. Now we have D and A, and these change signs. So then, like I said, this AD minus BC is the determinant of the matrix, which is basically just doing AD minus BC, all like that. And that would be the determinant. So some things say to just find the determinant. The only ones I'd require you to find the determinant for are 2 by 2 and a 3 by 3. I will show you how to do it on your calculator, but there will be times that I explicitly say do this by hand, or I may say you can do it on a calculator if I think that that's necessary. The determinant of a 3 by 3 matrix, okay, so this is the only other type that you would have to do for a determinant by hand, okay, but it's weird the process that it follows, okay, but we have this matrix with all these letters in alphabetical order here. Okay, so when we're taking the determinant, we write them that almost look like absolute value bars, but we use that to basically denote that we're taking the determinant. So when we do this, okay, we start here with this A, okay, then we close off everything else in that column, and then we take the determinant of these things in here, this group of 4. So it'd be just like up here, EI minus FH. So A times EI minus FH. Okay, and this, you can just follow this formula because everything's, you know, open notes, so you shouldn't really have to worry about memorizing it. In Algebra 2, I made them memorize it, but at this point, you guys can just use the formula. The second one is minus b. So minus b, cover up everything in that row. I'm trying to make it so you guys can, like, see what's going on here. Let's see if I can cover it up with this. Okay, there we go. So now everything's covered up. So now I'm using this square here to do it. So I have di minus fg. So negative b times di minus fg plus c. So cover up everything in c. And we do dh minus eg, which is what we get here. So that is the formula that you would use to do the determinant of a 3 by 3, which you will have to do by hand, and then I'll also have you check it on a calculator just to make sure that you can do that. Let's see, we think we have one more page of these notes, and we'll actually get into some problems. Alright, so inverse of an n by n matrix, this is a theorem. An n by n matrix A has an inverse if and only if the determinant of A is not equal to 0, which we kind of already had shown on the last thing, but if the AD minus BC is equal to 0, then it does not have an inverse, mainly because 1 over 0 is undefined, so we can't do that. Alright. Properties of matrices. These are just like normal properties of algebra. So we have matrix A, matrix B, and matrix C, and their orders are such that the sums, differences, and products are as defined. So commutative property for addition, A plus B is equal to B plus A. Multiplication does not hold in general, okay, because of the fact that we would have to have the correct order. So an m times n and an m times n matrix, you can't do. Now, if we have an n times n and an n by n, then it would hold. So it's not holding all the time, thus we can't say that that is actually a property that they have all the time. Associative property, A plus B plus C is equal to A plus B plus C, and the same for multiplication, A times B times C is equal to A times B times C. Identity property, we already talked about these. If we add matrix O, okay, or the 0 matrix to A, we just get A. Over here, 4. Now, there's obviously, because we're multiplying stuff, you still have to have the same order, but A times the identity matrix is equal to the identity matrix times A, which comes out to just be A. Inverse property, we already talked about this a little bit, but A plus the inverse of A, okay, or minus A is equal to 0. In multiplication, A times the inverse of A is equal to the inverse of A times A, which is the identity matrix, provided the determinant is not equal to 0, okay, because otherwise we wouldn't have an inverse. Distributive property, okay, they split it up into multiplication over addition and multiplication over subtraction, but, I mean, you guys know the difference there. So, basically, A times B plus C is A times B plus A times C, and then A plus B times C is A times C plus B times C, and so forth for subtraction. So, that's all the notes that we have for that, but I'm sure you guys would like me to do examples, and as a refresher to make sure we remember how to do this stuff. So, I've gone through already and picked a few that I'm going to work out. And so we are going to start with the stuff that is it wants you to determine the order of the matrix and tell whether it is square. Okay, so same number of rows and same number of columns. So we're going to start with number 2, 1, 3, and I'll always read the numbers going across and then down. So 1, 3, negative 1, 2, So the order of this one, we go rows and then columns. So 1, 2 rows by 1, 2 columns. Since those are the same, we say that it is a square matrix. Okay, or we say that it's square. Use a worksheet to focus this back in. It's kind of blurry. All right. Hopefully that's a little bit better. All right, let's see, number 4. The same instructions. -1, 0, and 6. So we have just one row times 1, 2, 3 columns. These are not the same, so it is not square. Next we want to find, I'm just going to do one of these, okay, but I'm doing a slightly harder one. So find A plus B, A minus B, 3A, and 2A minus 3B. We're going to do number 12. So A is equal to, it's going to be a 3 by 3, so -1, 0, 2, 4, 1, -1, and 2, 0, 1. And then B is 2, 1, 0, -1, 0, 2, 4, -3, -1. Alright, so the first one we're going to do is A plus B. Okay, and I want you to show your work this way. This will also help me to verify that you understand what you're doing. So you're going to rewrite these two with an addition sign between them. So -1, 0, 2, 4, 1, -1, 2, 0, 1, plus 2, 1, 0, -1, 0, 2, 4, -3, -1. So now I want to know what my resulting matrix is. Since these are both 3 by 3s, okay, we can add them. And so then my resulting is also going to be a 3 by 3. So we just match up top left with top left, top middle, and so on and so forth. So -1 plus 2 is 1. 0 plus 1 is 1. 2 plus 0 is 2. 4 plus -1 is 3. 1 plus 0 is 1. -1 plus 2 is 1. 2 plus 4 is 6. 0 plus -3 is -3. And 1 plus -1 is 0. So that would be the answer to that one. So now let's look at A minus B. So we're going to set it up the same way. -1, 0, 2, 4, 1, -1, 2, 0, 1, minus 2, 1, 0, -1, 0, 2, 4, -3, -1. So now I can do this one of two ways. I can either multiply this negative sign through everything and rewrite these with a plus sign between them, but you guys are in pre-cal. I think you can take care of negatives on each term, so I'm just going to go across and do my matrix. So -1 minus 2 is -3, 0 minus 1 is -1, 2 minus 0 is 2, 4 minus a -1 is the same as 4 plus 1, so that's 5, 1 minus 0 is 1. Negative 1 minus 2 is negative 3. 2 minus 4 is negative 2. 0 minus a negative 3 is the same thing as 0 plus 3, so that's 3. 1 minus a negative 1 is the same thing as 1 plus 1, so that is going to be 2. And then next we have 3a. So this one's going to be scalar multiplication. So basically we just stick a 3 out front of our matrix A. So negative 1, 0, 2, 4, 1, negative 1, 2, 0, 1. So we just multiply 3 by each piece. So 3 times negative 1 is negative 3. 3 times 0 is 0. 3 times 2 is 6. 3 times 4 is 12. 3 times 1 is 3. 3 times negative 1 is negative 3. 3 times 2 is 6. 3 times 0 is 0. 3 times 1 is 3. And lastly, we have 2a minus 3b. So we got to set this one up. This one I'm going to end up writing underneath of it for the sake of space. So 2 times matrix A is negative 1, 0, 2, 4, 1, negative 1, and 2, 0, 1. Now minus 3 times matrix B is 2, 1, 0, negative 1, 0, 2, 4, negative 3, negative 1. Alright, so the way I would recommend doing this is to go ahead and multiply this stuff through first and then go back and add everything. So I'm going to multiply the negative 3 through here and put a plus sign between the two matrices. So this new matrix is 2 times negative 1, negative 2, 2 times 0 is 0, 2 times 2 is 4, 2 times 4 is 8, 2 times 1 is 2, 2 times negative 1 is negative 2, 2 times 2 is 4, 2 times 0 is 0, 2 times 1 is 2, plus, because I'm multiplying this negative 3 through, negative 3 times 2 is negative 6, negative 3 times 1, negative 3, negative 3 times 0 is 0, negative 3 times negative 1 is 3, negative 3 times 0 is 0, negative 3 times 2 is negative 6, negative 3 times 4 is 12, negative 12, negative 3 times negative 9 is, negative 3 times negative 3 is positive 9, negative 3 times negative 1 is positive 3, and then this results in, I can add these two together now, negative 2 plus negative 6 is negative 8, 0 plus negative 3 is negative 3, 4 plus 0 is 4, 8 plus 3 is 11, 2 plus 0 is 2, negative 2 plus negative 6 is negative 8, 4 plus negative 12 is negative 8, 0 plus 9 is 9, and 2 plus 3 is 5. So now I'm going to show you how to go through and check these on your calculator to make sure they're correct. Okay, because I'm not sure if you've seen, actually here, slide this way. Not sure if you've seen these done on a calculator before, or how to put them in your calculator. So, calculator on. Now it's really hard to see because of lighting, but above this x to the negative 1 button, there's the word matrix. So you're going to hit second, and then that button brings up your matrix options. Okay, this is not where you want to click. Okay, you want to go over to edit, and in matrix A, now I have to put in what type of matrix I have. I had in this case a 3 by 3 for both, so I'm going to do 3, enter 3 to bring up a 3 by 3. And it's going to work across asking you to punch your numbers in. So negative 1, 0, 2, 4, 1, negative 1, 2, 0, 1. And I'd recommend you go through and check back and make sure you did them correctly. Okay, then just get out of it. So second quit. Then go back, second matrix, over to edit. But now I want matrix B. So now matrix A says it's a 3 by 3. So I'm going to fix matrix B to be a 3 by 3. Oops, maybe not. There we go. So now matrix B, reading it across, is 2, 1, 0, negative 1, 0, 2, 4, negative 3, negative 1. I would suggest you check and make sure you typed everything in right. Alright, then second quit. Alright, so now I want to do, first I want to check A plus B. So you're going to go to second matrix, and now is where you can use these functions here. Okay, so where it says names, that's where you're going to pull them if you want to use them. If you're going to change them, you have to edit over here with edit. And then we'll get to this math column here in just a second. So I want A plus second matrix B. And then it's going to bring up a matrix. So I can check 1, 1, 2, 3, 1, 1, 6, negative 3, 0. And so that must be correct. Now, just because I just need to change the sign, I'm just going to do second and then entry. Okay, and then change it to a minus sign. Now I can check this one. Negative 3, negative 1, 2, 5, 1, negative 3, negative 2, 3, 2. So that one was correct. Now I need to do 3 times matrix A. So you have to do the 3, second matrix, matrix A, hit enter. Now I can check negative 3, 0, 6, 12, 3, negative 3, 6, 0, 3. So that one was good. And then lastly we have 2A minus 3B. So I'm going to do 2, second matrix A, minus 3, second matrix B. So this one gave me negative 8, negative 3, 4, 11, 2, negative 8, negative 8, 9, 5. Alright, so remember, your calculator is a checking tool, okay, not a using it tool, okay? You're not using it to do these problems. If I don't see the work, you won't get credit, okay? Because your calculator doesn't show you all your work, so you got to show me the work for them. Alright, so let's see. Alright, so now we are going to use the definition of matrix multiplication. Words are running together here. To find AB and BA. So we're going to do number 18, and I'm going to show you how to actually multiply this one out. And then some of them we're just going to use our calculator for, but I'm going to kind of modify the instructions for some of them. So 18, we have matrix A is 1, negative 4, 2, 6. B is 5, 1, negative 2, negative 3. Alright, so I already know that I have a 2 by 2 and a 2 by 2, so when I go to do AB, I know I have 2 by 2 and 2 by 2. These middle two match, and then these outer two are my resulting matrix. Okay? When I go to do BA, I still have a 2 by 2 and a 2 by 2. Middles are still the same, so this outside is going to be the result. Obviously, this one's easy because they're both 2 by 2. When they're different, obviously, you kind of have to pay attention to that. So I'm going to set this up. 1, negative 4. Oops, that negative should be closer over there. 2, 6. 5, 1, negative 2, negative 3. So when we're multiplying these, okay, these are a little weird. You multiply the first one times the first one, then the second one times this one, okay? And you add those two numbers together. So what I mean is, in this first one, give yourself some space, 1 times 5 plus negative 4 times negative 2. Okay? Then over here, I'm going to do the same thing going across over here. So we have 1 times 1, negative 4 times negative 3. So plus negative 4 times negative 3. Now, when we get down to the bottom, we start over. So 2 times 5 and 6 times negative 2. So 2 times 5 plus 6 times negative 2. And then we do it again, 2 times 1 and 6 times negative 3. So then we just got to add these things up in here and get our answer. So 1 times 5, so that's 5 plus 8 is 13. This is 1 plus 12, so that's another 13. 10 minus 12 is negative 2. 2 plus negative 18 is negative 16. So that is a B. So you have to show me this step for the ones I require you to do by hand. For the ones that I allow you to do on a calculator, okay, you can just write this down, go straight to here, but you are going to tell me what the resulting matrix should be, basically. It should be the first thing that you tell me. Alright, so BA, so now we're just doing this in reverse. So 5, 1, negative 2, negative 3. 1, negative 4, 2, 6. Going to kind of run things together here. Alright, so 5 times 1 plus 1 times 2. Then 5 times negative 4 plus 1 times 6. Negative 2 times 1 plus negative 3 times 2. Negative 2 times negative 4 plus negative 3 times 6. And this gives us 5 plus 2 is 7. Negative 20 plus 6 is negative 14. Negative 2 minus 6 is negative 8. And let's see, this is positive 8 minus 18 is negative 10. So that's BA. Okay, and I would recommend you check these on your calculator. But since we're getting ready to do some on our calculator, I've already checked these ones, so I know that they're true. Okay, so here's the deal for how this is going to work. Okay, I'm going to give you some that you have to do by hand for homework, and then some that you can do on the calculator. But let's go ahead and look at 22 and see kind of what I'm looking for here. So or actually here, let's look at 20 first. 20, so we have two matrices to write them down real quick. So this is going to be, I had to grab my book, had it laying to the side. Alright, so this one is going to be A is 1, 0, negative 2, 3, and 2, 1, 4, negative 1. And then B is, oops, B is really long. B is 5, negative 1, 0, 2, negative 1, 3, 4, 2. Alright, so what you're going to do with one like this is you are going to just tell me what the two possibilities are, and then you're going to do it on a calculator. So the first thing you should do is you should say, because we're doing A times B first, so A times B, so this is a 2 rows by 4 columns, and this is a 1, 2, 3, 4 rows by 2 columns, so 4 by 2. These two match, so first of all, you're showing that that's good, okay, and so then the resulting is a 2 by 2. So we're going to end up with a 2 by 2. And then that matrix is going to end up giving us an answer, which we'll get in just a second. Go ahead and set up B times A, and then we'll do both of these in the calculator at the same time. So B was a 4 by 2, and A was a 2 by 4. These two match, so the resulting is going to be a 4 by 4, meaning this is going to end up being a big matrix when we do it. Okay, and not that you guys couldn't do these by hand, you do these the exact same way, but just to try to save you guys some time, you have a calculator, so I'm going to do that. So I'm only requiring you to do these like simple ones that way. So you're going to type in your calculator into matrix A. So you're going to do second matrix, edit. You're going to edit matrix A and make it a 2 by 4. Reading it across. 1, 0, negative 2, 3, 2, 1, 4, negative 1. Second quit. Second matrix. Over to edit. We're going to edit matrix B and make it a 4 by 2. So now we have 5, negative 1, 0, 2, negative 1, 3, 4, 2. Okay, and if I'm going too fast, just like pause the video and go back a little bit. Just try not to waste a ton of time. Second quit. Now I want to do A times B. So second matrix, A, second matrix, B. So that did result in a 2 by 2, and it gave us 19, negative 1, 2, 10. So 19, negative 1, 2, 10. So that's what I'm looking for here, was that you showed me that that would have been a 2 by 2, and then you actually gave me the 2 by 2 matrix. Alright, then B times A, second matrix, B, second matrix, A. It resulted in a 4 by 4. So it is 3, negative 1, negative 14, 16, 4, 2, 8, negative 2, 5, 3, 14, negative 6, 8, 2, 0, 10. Alright, so that's how to do one like that and what I'm looking for there. So then like, we're going to jump down and do 24. We're going to skip 22 because that one would follow the same process, and they're both 3 by 3. So 24, we have A is equal to negative 2, 3, negative 4, and B is negative 1, 2, and 4. And we're following the same basically instructions here. So this one, okay, still going to let you do this one on a calculator, but we would set it up. AB is, so A is a 3 by 1. B is a 1 by 3. These match, resulting is a 3 by 3. And then you would go through and fill in the 3 by 3 matrix. BA is a, so B is a 1 by 3. A is a 3 by 1. These two match, so I'm left with a 1 by 1, which is just one little block. Alright, so then on the calculator, we have going to go second matrix, edit, so it's a 3 by 1. So -2, 3, -4. Second quit, second matrix, edit B, which is a 1 by 3. And this is -1, 2, 4. Second quit, second matrix, A, second matrix, B. So that resulting 3 by 3 gives us 2, -4, -8, -3, 6, 12, 4, -8, -16. And then we need to do the reverse. So second matrix B, second matrix A gives us just -8. And that is all for that type there. Alright, so I think I'm going to pause stuff here really quick because for one, I'm recording and the weather's getting really bad and I don't want to risk losing this 40-some minute video if the power goes out. And two, I think I'm going to make the second part of this actually due next week. So just the multiplication and addition stuff is going to be due right now. So then your homework, let's see, I need to get a new page for that. Alright, so your homework here so far is, find my book again. Alright, it's 1 through 27 odd. Actually, here, let's throw out but not number 13. Okay, get rid of 13. I'll take out one of those like longer problems. Okay, then as far as this goes, 17 and 25 you're going to do by hand. Okay, but 19, 21, 23, and 27, you're going to do the modified instructions. Okay, on a calculator. So state resulting matrix. Order, so something by something, and then actually write the matrix. So that's what you have to do, and that is due Sunday, and then the rest of this will be due next week sometime, and we'll probably have a quiz next week, and we'll be kind of wrapping up stuff since we only have about 2 weeks left. So, hope you guys have a great rest of the week. If something happens and you lose power because of this rain and storm that's coming through, shoot me a text and let me know what's going on, and I'll work with you on getting that done and stuff. Hopefully nothing will happen, but just in case, you go ahead and cover that base. So, have a great day.